I built a machine learning model that tells you whether a car deal is actually good or if you're about to get ripped off. Right here, my model predicts this BMW M4 should be worth about $81,000, but the dealer is asking for $74,000. That makes this a great deal, over $6,000 under the market value. I know we have all wanted a flashier looking car in our lifetime. I mean, I'm caught. I just bought myself a Mustang GT. Some of us spend our entire lives scouring Facebook Marketplace for the perfect car deal that may not even exist, but trying to figure out if those Facebook Marketplace deals are actually good or not. Even most of the time, the big car websites just have a little deal sign next to them that says it's good, bad, or great. Which, what does that even mean? How great is great? So here we go. The first problem I have is I have absolutely nothing. And if you know anything about machine learning, you know that you need a lot of data to train some models. And 9 times out of 10, the more data, the better the model becomes. I was gonna use a website like Kaggle or some other website that has open source data sets, but I kind of wanted to be cool. So first, I needed to make a data set for my own liking. And second, I had to pick which car I was going to make this entire model on. And boys, if you know me, the car I went with was the Tesla. The car I went with is the BMW M4. I was looking for a while on how I can get data for some BMW M4s, and I came across this thing called web scraping. Essentially, instead of me going onto a website like cars.com and typing in every single spec to every single deal on the 1,400 different BMWs listed on the website, I basically make a bot or some sort of Python bot to basically go onto the website itself and scrape off every single piece of that data. But I needed to first open up the HTML file for cars.com. So going on cars.com, you can actually inspect the web page, and we had to figure out what type of classes cars.com was using. So for instance, the name that they give the car, so like 2025 BMW M3 competition, that is the class, but you have to look at what the class is called. So it's H2, which then we can classify and tell our bot, look for class for H2 or heading to. These big sites don't like bots at all. This happened time and time again. Trying so many different methods, I pretty much stayed up till 4 in the morning trying to figure out how I could make an HTTP call from my Python bot to cars.com. I literally just wanted to return one car. I wanted the first car that pops up, its price, its miles, and its name, and that's it. And finally, after hours and hours of trying to do this, I finally got it. Bro, I don't even know what to say. Holy Temu, I can't believe we got this John to work, bro. All right, we're gonna try and get this. Let's get this bread. I basically used a undetected Chrome driver. I kind of spent a little bit of time looking out on like how legal this is. I think because we are only scraping the data and not messing with the actual website, pretty sure we're chilling. I think.
You're done.
At first, I got it to return the first 5 BMWs that popped up on the first page. But I knew that 5 BMWs was not going to be enough data to train the model. We needed a couple hundred BMWs to train this model. Obviously, with more BMWs, it would have made the model better, which we might do in the future. Let me know. Leave a like on this video, just down below. Leave a like on the video if you guys. Essentially, I just wanted to scrape off of cars.com since I knew this was working, and I essentially made it go through every single page from 1 to I think it was 70, and basically just do a random scroll so it didn't think that I was a bot, and then just take the name, price, and miles from every single BMW listing as of right now or today. And just like that, I'm basically a data expert. There were some problems though. The name of the cars was actually a super long clump of information, which a lot of this could actually be turned into more features. The year, how old the car is important to us. If it's a competition model or not, and if it's rear wheel or all wheel drive. Also, I noticed when I was flipping through a lot of my data, a lot of the miles came out to NA or not available. I essentially made it, if you couldn't find the data for the mileage, just label it as NA or not available. I flipped through a lot of cars.com to see why it wasn't grabbing these type, and 9 times out of 10, if not 10 times out of 10, it was because the car was brand new. So essentially I would fix it so the mileage would be 0 and label them as new opposed to used cars. I basically calculated the percentage of new cars to the percentage of the new cars, and I basically had to see if we had too many new cars. And to my surprise, they came out pretty even. If we had too many new cars, we couldn't really use this data set and we would have needed more data. The mileage is a very important feature that changes the price a lot on these cars. Now that I had 1,400 different BMW listings from cars.com, it was time to make the machine learning model. I went with random forest regression. I knew we didn't need deep learning, as like I said before, it was pretty simple to take the averages of all these. Plus, random forest regressor has produced great results for me in the past. In the future, I might try and compare this to other machine learning models like KNN or support vector machines. For now, this will do. I tried with a couple of different amounts of trees. I tried with 100, 200, and 400, but it didn't really knock down the average price error coming out. The R squared value came out to a 0.95, which is actually very good. So good that I almost had to check to make sure that this entire model didn't overfit, especially since I had no parameters on this thing. I then tested this machine learning model with a random 2023 BMW M4 with over 15,000 miles with a competition package and an xDrive package, and checked it with Kelley Blue Book. So actually this model was pretty accurate, and I was actually super surprised and I was super hyped with the results. I also compared this with 50,000 mile and it came out exactly how I hoped. Now, I want to preface this, the prediction that comes out of our model. So for instance, our 2023 BMW M4 came out as 80K. The way you tell if it's a good deal is if the car is actually listed below that value, that is a good deal. And then you can actually subtract the value of what we were given as a prediction subtracted by value of the listing, and basically that is how good the deal is. So it'll tell you, okay, yeah, you're saving $3,000 on this, you're saving $5,000, and that's how you can tell how good it is. And I'm gonna make a GUI for this where essentially it'll just do the calculation for you. In the future, I might try and incorporate a method to tell if the car has been in accidents or not, because as of right now, it doesn't factor that in. And if you're looking at Facebook Marketplace and you're seeing that the car has been stolen 3 times, it might still list it at $70,000. But overall, this project was really fun, and now I can test how good my Facebook Marketplace deals are. So let me know what you guys want to see in the future. I hope you guys enjoyed. If you stay to the end, you're an absolute stud. Peace. I was gonna use some websites like Kaggle or some open source websites. It's not an open source.